Hi everybody, I'm Mr. Rada. Today we are talking about computer science for a school certificate and the topic will be check digit. Now this is my Google Classroom. You can join this classroom for free. Okay, and the class code is given here. This is your class code. Next, again the class code is here. Now check digit, it's on page 60. Let's go for it. So what is check digit? What is check digit? It is an extra digit added at the back of the original number. It is a digit that is calculated using a mathematical algorithm. The mathematical algorithm can be modulus 11 and there is a variety of other algorithms. Check digit, it validates a number. It checks whether the number is correct or incorrect. Okay, like where check digit is used. Check digit is used to check barcodes, to check product codes, check ISBN number, to check vehicle identification number, bank account number, and credit card. So check digit is used to identify if there are input errors, to check data entry such as mistyping, misscanning. So check digit, check if the digit has been inverted. It's called transposition error. For example, in this case, 5 has been swapped between 5 and 4. Incorrect digit has been entered. Like for example, instead of a 5, 4 has been entered. Or digit has missed out. For example, you miss out the 4. So check digit detects errors. What types of errors? Incorrect digit has been entered. Transposition error, position has changed. Omission of an extra digit. Or phonetic errors like 13 has been misinterpreted as 30 instead of 30. Now let's look at an example here. How check digit is calculated for ISBN number for book using an algorithm called modulus 11. Now remember, if when the check digit is 10, we cannot write 10 two digits. We have to write it as a letter X. Okay, let's look at this example. How to calculate the check digit of an ISBN number. Now this is our ISBN number. The check digit we don't know. That's why we put question mark. So what we do, we write the ISBN number. If we don't know the check digit, we put a question mark. Now we write each digit position. For example, here position 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So these are the position of the digit. Now what we do, since we don't know the check digit, we cannot start with position 1. We start with position 2. Okay. So digit 2 is multiplied by the position 2. Digit 8 is multiplied by its position 3. Digit 0 is multiplied by the position 4. Like this. Like digit 3 is multiplied by the position 5 and so on. Digit 5 is multiplied by the position 6. It goes like this. Each digit is multiplied by its respective position. But when you multiply, what you get? The products. What you do with the products? You add the products. When you finish adding the product, you get the total. Next step is you divide the total by 11 because the algorithm is modulus 11. When you divide by 11, you get a remainder. The remainder is 10. Then 11 minus the remainder because you are doing modulus 11. So remainder 11 minus 10. 11 minus the remainder, which is 10. The answer is 1 and the check digit is 1. Now what we do is the check digit 1. We put it at the back of the original number. This is our original number and we put the check digit at the back of the original number. So now when we transfer this ISBN number together with the check digit, what will happen at the other computer? they will take the original number, they will recalculate the check digit, and these two check digits will be compared. The check digit which is 1 already here, and the calculated check digit, if it is 1, if these two check digits is the same, it means that the ISBN number is correct. But if these two check digits are not the same, then there must be a mistake in the check digits. There must be an error. Now let's take a second example. In this case, you have ISBN number, and at the back you have the number X, which is a check digit. Okay, remember that X represent the number 10. So X, we recall, is the number 10. The check digit is 10. Now in this question, we are going to check if the number is correct or incorrect. Now we multiply each, we put the numbers. Okay, this is a number. We write the position. Okay, like this, position 1, 2, 3, like this, 3, 4, and so on. Now we multiply each number by the respective position, that is X times the position. Then 7 times the position, 2. 7 times the position. So each digit is multiplied by its position, like 4 multiplied by 3. The 4 multiplied by the position 3. And so on. When you finish doing the multiplication, all the multiplication, you finish this. What you get, the product, you add the products. Okay, you get a total. Now what you do is the total, you divide the total, in this case is 132 by 11, and you get a remainder of 0. If you get a remainder of 0, it means that the number is correct. Okay, if you don't get a remainder of 0, it means the number is incorrect. Now let's take another example here, example 3. Example 3, you have an ISBN code. Okay, and the last digit is a check digit. So if we look at this, now a new algorithm is given to you now. This new algorithm means step by step you have to follow it. It's not modulus 11. Another algorithm is given to you. Now in this algorithm, what you do, you have the barcode. You have to write the position. Okay, we take the barcode. This is the barcode, and we write the position. Now this is position 1, position 2, position 3, and position 4, and so on. Okay, this is 2. Okay, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. Now the odd positions, we call them odd position, and we have even position. What we do now, we take all the number of odd position in this case. So odd position is 1. At position 1 we have 9. Position 3. Okay, 9 is an odd position. Then 3. Position 3 is 8. And then position 5 we have 3. So we take all the odd position like 9, 8, 3, 0, 8, and 8. We sum them. We get a total. And we take all the even position like 7, 0, 4, like here 7, 0, 4, 9, 3, and 2. We sum them. But for even position, let's multiply them by 3. So you add them, then you multiply by 3, you get a total. Now next step, you take the odd and the even, you add them, you divide by 10, you get a remainder. If the remainder is 0, the check digit will be 0. But if the remainder is not 0, then 10 minus the remainder will get a check digit. And in this case, the check digit is 9, and we can check it is 9. We put it at the back of the original number. Now, how can you check that the check digit is correct or incorrect? Same thing, you add all the odd numbers, okay, including the check digit in this case, to check whether it's correct or incorrect, and you add all the even digits together, you multiply the result by 3, you 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 add the result from 1, that is odd, and the result from 2, which is even. You divide by 10, and if the remainder is 0, it means that the number is correct. But remember, in this case, to check the correctness, we have to take into consideration the check digit also. So let's take this example. We have added all the odd position digits, we get 45. We have added all the even position all the even position digits, we multiply them by 3, we get 75. So 45 plus 75 divided by 10, we get a remainder of 0. Since we got a remainder of 0, it means that the number is correct. Now let's take another example 4 now. Now in this photo you can see it's not that clear, but it's okay. This is a barcode, okay, and this is barcode lines of vertical thickness. So barcodes are made up of dark and white lines of varying thickness, as shown in the figure. Now the barcode consists of 4 parts: the country code, the manufacturer code, the product code, and the check digit. Now check digit is a form of validation to check that the number is correct, to make sure that there are no errors when reading it, when scanning it. So check digit can be calculated in a number of ways. There are different algorithms. Earlier we have looked at modulus 11 and other methods. Now in this case, another method is being used. We have 11 digits, and at the back we have the check digit. Now remember, we have this one is as position 1, this is 2, position 2, this is position 3, and it goes like this. So all the odd position means position 1, 2, 3, odd positions are 1, 2, 3, 5, 7, 9, and 11. They are odd position. Now digits as an odd position of 5, as you can see. This is the original number. So digit at the odd position will be this one, odd position. 5 is the odd position, and 0 is the odd position, and then 3 is the odd position. So what we are doing, position 1, 3, 5, 7, 9, and 11, the digits, we are adding them together. Okay, we are adding them together. So we get a total of 16. Now, in this case, it's different. We are taking the odd positions, the total, and we multiply the odd position by 3. We get 48. Now, let's look at the even position. Even position means position 2, 4, 6, 8, and 10. What are the digits at the even position? Again, 1, 4, 1, 2, and 1. So we take the digits of the even position. The sum is 9. What we have to do now, take the 16 odd and the even 9. The odd is 48 and the even is 9. We add them together. We get a total of 57. Now what we have to do with the 57? We divide it by 10. So 57 divide by 10. Okay, divide by 10. We get 5, and remainder is 7. Now what we have to do? 10 minus the 7, we get a 3. So the check digit is 3. Is it not nice? So we put the 3 at the back of the original number. So you have the barcode plus the check digit. So you have seen the algorithm changes. So in the exam you have to follow the algorithm, the steps given. Next. Now again, when the barcode is read, the check digit is recalculated and then compared if they are correct. If it is correct, the number is okay. Now this is an activity. You can try this activity, and the answer I have already given here. for 1 and 2. Now for the second one, you will see that the remainder is 0, and we have said if the remainder is 0, the number is correct. Now let's look at specimen paper 2015. In this case, a company sells CDs. Okay, now this is a unique number, identification number, and 9 is a check digit. We write the digit position 1, 2, 3, 4, 5, 6. Now what is the algorithm in this case to check the validity of the check digit? You multiply each digit by the position, you add the result, and you divide by 11. If the remainder is 0, the number is valid. Otherwise the number is invalid. Now let's try this number. This is an identification number. We have to write the position. So we write the position 1 here at the top. We write position 1, 2, 3, and so on. So then you multiply the number with the position. 3 times 1, you can see. Then 2 times 2. Then 9 times 3. And 1 times 4. And 2 times 5. And 4 times 6. When you finish multiply, you add the products, the results. You add them one by one. And you finish adding, you get 72. You divide the 72 by 11. In this case, the remainder is 6. It means the number is not valid. It is invalid. Okay, let's take another example. This is a number given to you. 6 is a check digit. We write the position. Okay, 1, 2, like this, 3, and so on. You go like this. Then you multiply the number with the position. 6 times 1, like this. 6 times 1, 5 times 2, 1 times 3, and so on. After multiplying, you sum the products. You divide the total by 11. And in this case, the remainder is 0. It means that the number is valid. Now, in this case, you have to calculate the check digit to find the check digit. Now again, what you do, you don't know the check digit, so it's a question mark. Okay, and you write the position. What is the position? 1. This one is 2. Okay, sorry. Then the next is 3. But you start with position 2. Why do you start with position 2? Okay, because the check digit you don't know. So I try it for you. This is position 1. This is position 2. This is position 3. Like this is position 4. So we start with position 2 because we don't know the check digit. So 1 times 2, 4 times 3, and 2 times 4, and 0 times 5, and 5 times 6. After doing the multiplication, you add the products, you get a total of 52. Okay, and then you divide it by 11. Then you subtract the remainder from 11. You get the check digit as 3. Okay, 11 minus the remainder, you get 3. So 3 is the check digit. That's how you find it. So if we can do it for you, wait, yes, so 52 divided by 11, you get 52 52 divided by 11. Let's try it. You get 4. Wait, now I can try this. Now 52 divided by 11, then 11 minus the remainder. Okay. Next, describe with examples. Wait. So I want to cut. Now